All right, so we are going to be starting to talk about the unit circle specifically. And a good place to start is the values that happen at the quadrantal angle. So the trig values that happen at the quadrantal angles. So 90 degrees, 180, 270, 0, 360, or their equivalent radian measurements. I'm going to be talking about radians a lot more. So just, be prepared for that. Make sure you're thinking about things in terms of radians. So we're gonna do one of these and then just kind of fill in the rest of the table just to sort of talk about it. So I'm going to be focusing on the 90-degree angle or the pi over 2 angle. So, sorry, wrong direction there. So we have our initial side and then our terminal side. So on the unit circle, the point that would pass through is this point right here, the 0, 1. That's our x and our y. And of course, since we're on the unit circle, obviously our radius is in fact 1. Okay, so using those, right, we've already defined all of our trig functions in terms of x, y, and r. So we can go ahead and just sort of figure out what these values would be, right? So on the unit circle, the sine of pi over 2 is equal to y over r. So 1 over 1, 1. Oh, I'm filling out the wrong one, sorry. Pi over 2, 1. So I'm going to be filling out this row right here, the 90 degree, the pi over 2 row. Just kind of talk about it. Right? Cosine is equal to the x over the r, so 0 over 1, 0. Tangent is equal to y over x, y over x. That's a problem. That means that is undefined. That is not a value. We cannot take the tangent at 90 degrees. That's interesting. Next one is cosecant. So cosecant is r over y. So r is 1 over y is 1. So cosecant here is 1. Secant is r over x. So that's 1 over 0, which again, just like that, is undefined. And then the last one, cotangent, is x over y. So that's 0 over 1, which is just 0. So just kind of going through that, how we get it there. On the unit circle, some of this stuff is obviously a little bit easier. So instead of y over r, since r is just 1, we can just think about this as y. And instead of x over r, we can just think about this as x on the unit circle. And then these other ones a little more complicated. This is really 1 over y, 1 over r, or sorry, 1 over x, and then x over y. So some of these can be simplified since we do know on the unit circle r is actually 1. So point being here, some of the values like these are going to be undefined. We're going to get x coordinates, y coordinates, some combination thereof. And yeah, so let's just fill out the rest of this table and kind of take a look at what it looks like. I'm going to clear some of my drawings here. So notice how some of these are not defined, like cosecant is not defined at 0 or 2 pi because it's 1 over the y coordinate is 0. Or secant is not defined at 270 or 3 pi over 2 because it's r over x, or 1 over 0, again, not defined. On the unit circle, just going to kind of spill the beans here on it. The points around the unit circle are super useful. All the points around the unit circle, they essentially tell us the sine and cosine values. All of our points are going to be cosine of the angle at that place divided by sine, and then comma sine of the angle of the place. So the x is equivalent to the cosine value there. The y is going to be equivalent to the sine value there. So cosine here is 0. Cosine here is -1. Sine here, 0. Sine here, -1, right? So wherever we're at, the xy coordinate pairs that we get. So if we're over here and we get that we have a point that's -√3 over 2, comma 1/2. And that's what it is at this particular angle. And that's the cosine value, that's the sine value, that's the power of the unit circle. That's what we're going to be using. And we're going to be kind of memorizing certain parts of it. In particular, quadrant 1. Quadrant 1 is where we can kind of reference everything based off of quadrant 1. So to get some of these standard angles, 30-degree angles, 60-degree angles, 45-degree angles, we would sort of need to prove some of these things, and they're based on the relationships that you probably already know a little bit. So this is a kind of quick proof of how we come about with the trig values for 30 and 60, the exact values that we come up. They're based on the 30, 60, 90 triangle that we end up with. Feel free to look through this, kind of see where you get, but what I really need you to know is what happens, right? So once we end up here with our 30, 60, 90 triangle and we got our side lengths, it's easy to see that, for instance, if we're talking about a 60-degree angle, the sine of a 60-degree angle is the opposite over the hypotenuse. It's √3/2. The cosine of a 60-degree is the adjacent over the hypotenuse. Kind of go through this, right? Tangent is opposite over adjacent, √3/1. And then when we change our angle, once we're no longer talking about the 60, right? We got to change things up a little bit. When we get our 30-degree angle now, that changes things up a little bit, because now we have a 30-degree angle. We have this one as the opposite. Hypotenuse stay the same, and now this one's our adjacent, right? Because the opposite's across the triangle. So the sine of 60 is opposite over hypotenuse, 1/2. Cosine of 30 is adjacent over hypotenuse. Tangent of 30 is opposite over adjacent, 1/√3, or √3/3. These are the exact values that we're going to need to really focus on and know. So sine and cosine of 60, sine and cosine of 30. I'm not going to really expect that we memorize tangent. It can be handy, but we can also always figure it out just based on what we know about sine and cosine. For the most part, the stuff that we're going to need to memorize in this class are the properties associated with sine and cosine. We can kind of figure the others out or look them up as we need to. So there we go. So 30-degree and 60-degree angles covered. Remember, a 30-degree angle is actually the same thing as pi/6. 60-degree angle is pi/3 in radians. So radians are important. We're going to do them in radians and degrees, but try to talk about radians more and more. The next one that we deal with a lot is 45-degree angles and multiples of 45-degree angles. And so very similarly, this is based on a 45-90 triangle. On the unit circle, we have a radius of 1. So we can set up this Pythagorean theorem problem here to figure out that the dimensions of this if the radius is 1, that these sides are √2/2, which means that our x and y coordinates here are √2/2. And so the sine of this angle is √2/1, √2/2/1. Cosine of this angle is adjacent over hypotenuse, √2/2/1. And then tangent is y/x, same thing. So √2/2 divided by √2/2 is 1. So this one's probably an easy one to remember. Sine of this angle, cosine of this angle, there we go. In radians, we're talking about a pi/4 angle. Pi/4 radian angle is 45 degrees. These are the trig values we want to know. These are the unit circle values that we want to know. The cosine is the x, the sine is the y. Anyway, let's take a look at quadrant 1, because again, quadrant 1 of these unit circles is the one we need to be most familiar with. All of the other quadrants and angles can be figured out based on this, because we'll find a reference angle and we'll say, okay, the angle in another quadrant, we can use a reference angle of 60 degrees, and then the coordinates based on that. So knowing these angles is important. Again, they're all just based on our, like this one around here is a 30, 60, 90 triangle, and that's how we get our values. This one here with this angle, right, this is a 45, 45, 90 triangle. And then down here, this one also is another, this one's a 60, 30, 90, a 30, 60, 90 triangle. So we can see how these things are sort of repeating. The thing we need to know about the unit circle, the coordinates around the unit circle give us the sine and cosine values. So for 30 degrees, or pi/6 radians, the cosine value is the x coordinate. That's our cosine value, is the x coordinate. And the sine value is the y coordinate at that particular angle, right? At that particular angle. So the cosine of pi/6 is this. The sine of pi/6 is 1/2. If we change the angle, we change the values, right? So if we change it to a 45-degree angle or a pi over 4 radian, right, we're doing cosine is root 2 over 2, sine is root 2 over 2. Knowing the quadrant 1 will really help us fill out the rest of the unit circle, understand the rest of the unit circle, because everything is going to be some sort of multiple of these angles and referenced based on these angles. So knowing these really well is going to help us and be important. All right, so here's the full unit circle. A little overwhelming, but again, our focus is really, really needs to be in the beginning, making sure we understand quadrant 1. But you can sort of see, all right, if we deal with an angle, so let's say we have this angle here, the 60-degree angle or the pi over 3 radians, that is the reference angle for this one, right? Same angle, because the reference angle, remember reference angles, we drop down to here, to the x-axis. This is the reference angle for that is this one. It has almost the exact same sine and cosine values. The only thing that changes is because we're in a different quadrant, some things might be negative or positive and differ by a sign. It's the exact same except because we're on the left side of the graph, our x-coordinate is negative, but otherwise it's the same. Same idea here. If we're dealing with an angle like this one, in quadrant 3 down there, well, our reference angle is right here. This is a 45, so it should have the same coordinates as a 45. And look, it does. It's root 2 over 2 and negative root 2 over 2, negative root 2 over 2, right? It's the same, but because we're in quadrant 3, we're on the left side of the graph, we're on the bottom of the graph, our x, y coordinates are negative, so our sine and cosine values are going to be negative here. So understanding that one quadrant and how we can use it to reference everything else is going to help us solve these problems a lot better. Eventually, we'll start memorizing them. You'll want to have a unit circle handy as we're doing all these problems, but there it is. Big important thing to remember is the points are always written cosine of the angle here, comma sine of the angle here. Very useful. If you got the coordinates, you got the sine and cosine values. All right. We will look at some examples of this in class. I'll see you guys later. Bye.